Okay, let's take this problem. So I'll send the link in the chat. Okay, we are given an array. Excuse me. Okay, so basically we are going to have a bunch of ones and zeros, right? As the first example says, we are going to have an array like this. Then we are going to divide them into three parts, and the binary representation of all of those three parts should be the same. And how are we going to divide these array. So first of all, each of the parts will have the same number of ones, right? So with that being said, we're going to divide first we are going to divide the array into 3 parts, and each parts will have the same ones. And then we can start from the last part, and okay, so we are going to start from the last part. So we already know what is the suffix of the last part, right? We don't know the prefix of the last part because the last part could have more zeros, right? But we can deduct the suffix of the last part, which means we are able to know what it look like for the first part, right? Because in this case, the last part is 1. That means the first part is 1 as well. So the cut for the first part must be here. And then if we get with that being said, we can also know what is the middle part look like, because since the suffix have to be 1, the cutoff for the middle part also has to be here, right? And with that, we can just check if the 3 parts represent the same value, right? That is basically what described in the solution. Yeah, so basically, first we are going to divide the number of ones by 3. So each part will have t ones. Then we can find the position of the first t plus 1, the position of those ones. 3, they represent 3 intervals, right? So the zeros after J3 must be included in each part, right? That is saying that the third part, the suffix of the third part defines the suffix of all other parts. Yep, I guess that's it. So we put a check mark on this problem and move on to the next. Hello? Can you guys still can hear me? I'm not actually sure of that. Hello? Hello, 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 hello. Oh, we have a green bar here, so you guys still can hear me. Cool, that's great. Okay, let's take a look at this problem. So for in the example, we are going to have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. We're going to have 8 positions, right? And station 0 is at, should I call it station 0, city 0, city 1? I guess city 1 it is. Okay, so city 1 locates at here, 2, right? And city 2 locates at position 3. City 3 locates at position 6. City 4 locates at position 8. City 5 locates at position 4. Cool. Let's combine these two layers. Merge layer down. And then create a new layer. And we are going to scratch on it. So our goal is to move from city 1 to city 3, right? And our initial fuel is 5. And if we move from position 1 to city 1 to city 2 first, we are going to still have 4 fuels. And we can move here to here. Right, and down. This is a possible route. And what about 1, 4, 3? 1, 4, 3. Right, from here to here, it costs us 6. What? Why you want to move 1 to 4? Please tell me. The difference is actually 6. Huh, what is that? I may not understand the problem correctly. Actually, the city may start from 0, right? Oh, fuck. Right, the cities start from 0. My God. We may have to start this over again. That's confusing, man. You should tell that in the description. So it's 0, 0, 1, 2, 4, right? Reach down, create a new layer, and the first route 1, 2, 3. Our goal is 1, 2, 3, right? And we can move from 1, 2, 3, 1, 2, 3, and we can move from 1, 4, 3, 1, 4, 3, and 1, 4, 2, 3, 1, 4, 2, 3, right? Okay, that makes sense now. So looks like a dynamic programming to me, and we're going to have F I J. So I is the current city we're at, and J is the fuel we are having, right? And we are going to grad BFS it, right? Let's see. Okay. So we are going to have a priority queue, and the key value should be the field. And each time we get a new state that is saying that this is the number of total possible routes if we arrive at a city I, and having the field J, right? And if we are going to process this value, that means we already visit all the routes that can arrive to this state. And since we are having a priority queue, that means all of those states already still in the queue has equal or less field. Have more, actually have less or equal queue as current states, right? That means there will not be new updates on this state, right? Because the field only decrease. So what we are going to do with this state? So we are going to update other states with the value in the current state. So if we are going to move to a new state with current state, we are going to first check all the neighbors of the current city. That can be all of those cities. So we are going to iterate each of the cities, and we're going to calculate the cost to move to the next city, and the next city with the field will be updated by the current status, right? Okay, so that's that. Locations, current city, and field, right? So these two are our states, right? Cool, that's it. I'm going to have my lunch. See you guys. Let's see how